All right, so probability. So we're going to look at sample spaces and probability functions, determine probabilities. So the probability of an event happening is the number of positive outcomes, the number of outcomes that you want. It might not be positive, it could be a negative thing happening, but the number of outcomes you're looking for out of the total number of outcomes in the set, okay, in the sample space, okay? So if you're rolling two die, okay, you have two die that you're playing in a game. You could, what's the only way to get a 2 if you roll two die? You roll a 1 and a 1, okay? To get a 3, you could roll a 1 and a 2, or a 2 and a 1, okay? Because you might have a red die and a blue die. The red could be 1, blue 2, or red 2, blue 1. To get a 4, you could roll a 1 and a 3, a 2 and a 2, or a 3 and a 1, and so on. So there's 3 ways. So these are all the probabilities of rolling those outcomes, okay? And we can write it out. Find the probability of rolling a sum divisible by 4 on a single roll of 2 fair dice. Okay, so a sum divisible by 4. So if we go back, 4 is divisible by 4, 8 is divisible by 4, and 12 is divisible by 4. So you have a 3 out of 36 chance, a 5 out of 36 chance, and a 1 out of 36 chance. So if you add them all up, you get 9 out of 36, which is 1/4. Okay? Because you take each of those chances. All right. So probability has to be in between 0 and 1. Because the sum of all the probabilities has to add up to 1. The probability of something not happening would be 0. All right, Dylan opens a box of a dozen chocolate creams and offers 3 of them to Russell. Russell likes vanillas the best, but all the chocolates look alike. If 5 of the 12 are vanilla, what's the probability that all Russell's picks will be vanilla? Okay, his first... All right, so Russell's first choice. What's the probability of him choosing a vanilla cream? There are 5 vanillas out of the 12, so it's 5 out of 12. Now let's say he chose a vanilla. Then his next choice of choosing, how many vanillas are left? 4. How many chocolates are left? 11. So then he has a 4 out of 11 odds. Okay. Then the next choice he has, if he happens to pick right the first 2 times, he has 3 out of the 10 that are left. And instead of adding, this is multiplying. Okay? The probabilities of all of his picks have to be vanilla because you got these choices. Now, when we do this, okay, you can multiply the top, multiply the bottom, and reduce. The problem with that is some of these get really, really huge. Okay? So what's 4 times 3? 12. So 12 over 12, those cancel out. The 4, come on. The 4 and the 12 is 1 and 3. The 3 and the 3 are 1 and 1. The 5 and the 10 are 1 and 2. So you should have a 1 out of 22 chance of getting all 3 vanillas. Now if we look at that, hey, there we are. Now, they use a combination to do that, okay? But we wouldn't have to do it that way. I kind of like the way I do it. Oh, all right. We'll look at things when we look at the worksheet here. So, the worksheet. A pair of dice are rolled. What's the probability of getting the sum of a 6? Okay. When you roll dice, okay, to get a sum of 6, you could get a 1 and a 5, a 2 and 4, a 3 and 3, a 4 and 2, or finally a. Now, there's 36 possible ways of rolling dice. Okay? So these are how many ways? 5 out of the 36 ways. Now, we could draw out a whole chart of doing it, but just understand there's 36 ways when you have 2 dice. When there's 3 dice, I think there's 216, because you just take 6 to the third power. Okay? Because there's only 6 ways of rolling 1 die. If there's 36 ways of rolling 2 die, that's 6 squared. 3 ways would be 6 cubed. 4 ways would be 6 to the fourth power, and so on. Okay, rolling 2 pair dice. What's the probability of getting a sum less than 8? Okay, well, 2 is a sum less than 8. 3 is a sum less than 8. 4 is a sum less than 8. 5, 6, and 7 are all sums less than 8. What's the probability of rolling a 2? 1 out of 36, and this is 2 out of 36. This is 3 out of 36. This is 4 out of 36. This is 5 out of 36. And 7 is the best chances of rolling out of 2 fair dice, because you have 1 and 6, 2 and 5, 3 and 4, 4 and 3, 5 and 2, 6 and 1. So that's 6 out of 36. And then it starts going down after that. So you take 1 plus 2 plus 3 plus 4 plus 5 plus 6. So that would be 21 out of 36. Now we have to simplify that. How does that simplify? 7 out of 12. Okay. A sum of 2 or 12. A sum of 2 is 1 out of 36. A sum of 12 is 1 out of 36. We just add those together to get 2 out of 36, or 1 out of 18. A maker of candy comes up. So basically we're dealing with M&Ms. Okay. But usually they don't have pink M&Ms. But back in the day, they had tan M&Ms. Why? Because they said red M&Ms caused cancer back in the day. So they took out all the reds and they started making tan ones in its place. So when I was growing up, there was tan M&Ms and not red M&Ms. All right. So you have the probabilities of drawing colors. What's the probability of drawing a red or a pink? So if it says or, you add the numbers together. If it says and, you multiply them. So the red is 1 out of 10, because it's 1/10. The pink is 2 out of 10. So you have 3 out of 10, or 0.3 chance. What's the probability it is blue? Okay, it would be 3 out of 10. Oops. What's the probability that it is neither white nor pink? So everything except for white or pink. So blue plus red plus green plus tan is 0.4, 0.5, 0.6, so 0.6. Just add them together. All right, maker of candy comes up. What's the probability to find that 2 candies have the following colors? What's the probability that you choose one that's red and then choose another one that's red? So red and red That's an and, so you multiply them. Red and red, if you multiply them, are 0.01. Okay? So I'm pretty sure that 0.01, yep. Okay, one red and the other orange. You take red times orange. So it's 0.02. What's the probability that neither candy is brown? If brown is 0.2, not brown is 0.8. So if you pick and not 0. And you get 0.8 for your first draw, and it says neither candy is brown, so you have to draw again. And so you're going to draw another 0.8, which is 0.64. Probability that neither is brown. Okay, suppose 8 cards are drawn from a well-shuffled deck. What's the probability that all 8 are diamonds? Now this is the nasty problem. Okay, so what's the probability of drawing a diamond out of the 52 cards when you first pick out a card? How many diamonds are there in a deck of cards? 13. Okay, there's 13 out of the 52. Then the next time you draw a card, how many are left? 51. So you have a 12 out of 51 being a diamond. And then 11 out of 50. Then a 10 out of 49. Then a 9 out of 48. Then an 8 out of 47. Then a 7 out of 46. And is that 8? 1, 2, 3, 4, 5, 6, 7. Then a 6 out of 45. Okay? So, we got to reduce this. Okay, what's the best way of reducing this? Well, you start finding numbers that go into each other. 13 and 52 is 1 and 4. 12 and 4 is 1 and 3. 3 and 51 is 1 and 17, I think, right? 17 times 3 is 51. 7 and 49 is 1 and 7. 10 and 50 is 1 and 5. 8 and 48 is 1 and 6. And then we cancel the 6 with a 6. 11 doesn't go into any of these. So basically, 9 and 45 is 1 and 5. So my tops, all of them multiply to be 11. My bottoms, you multiply them all together because they want a fraction. So it's 1 times 17 times 5 times 7 times 47 times 46 times 5. Whatever that denominator is, it's pretty huge. 6,431,950. Okay? So you just do it that way. Okay. If it rains tomorrow, the probability John will play his guitar is 0.5. If it doesn't rain tomorrow, there's only a 0.4% chance that he'll practice. The chance of rain is 50%. So you take the 50% that chance that it'll rain times the 50% chance that he'll practice the guitar, plus, if this was 60, you take 60 and then 40, because the chance it won't rain is then also 50% times 0.4. You multiply them, you get 0.25 plus 0.2. There's a 0.45% chance that it'll play the guitar. Okay? So you just multiply the chance of rain times the probability and add it to the chance that won't rain to the chance it won't, and multiply the chance that won't rain times the chance that he'll play the guitar. All right, last one. Okay. An executive committee consists of 11 members, 6 men, 5 women. 4 members are selected at random to attend a meeting in Hawaii. The names are drawn from a hat. What's the probability that all 4 are women? Okay. All right. So, the first chance out of getting a woman is a 5 out of 11 chance. The second draw is a 4 out of 10, then a 3 out of 9, then a 2 out of 8. Then we reduce. 4 and 8 is 1 and 2. Then 2 and 2 cancel. 3 and 9 is 1 and 3. 5 and 10 is 1 and 2. So my whole top is 1. My bottom is 11 times 2, which is 22, times 3, which is 66. A 1 out of 66 chance that all 4 are winning. Okay? So the first assignment is probabilities, fairly basic. And you multiply or you add. Go from there and see what you can do.